Hi everyone, in this video we're going to talk about transformations of functions. So basically what we're going to do is we're going to take a function and then we can see how it moves as we add or subtract or multiply things to it. Okay, so the first thing we're going to talk about, there are three types of transformations that we're going to talk about. The first thing is what we call shifts, or we also call them translations. Second, we have reflections. And then the third, we have stretching or stretch and compression. Okay, so let's look at the first one, which is shifts. Okay, so the first transformation that we're going to do is shifts, right? Now there are two types of shifts that we're interested in. One is what we call the vertical shift. And second is what we call the horizontal shift. Okay, so let's see, what is the vertical shift? Okay, so let's take three functions. I have fx equals x squared. All right, that's what we'll call our base function. We have gx, which is x squared plus 2, and then we have hx, which is x squared minus 3. All right, so we're going to see how are gx and hx different than fx. All right, so let's go ahead and make a table here. So I have x, I have x squared or fx, then I have x squared plus 2 or gx, and then finally x squared minus 3 or hx. Okay, so I'm going to pick 5 points. I'm going to pick -2, -1, 0, 1, and 2. When I square these numbers, I get x squared becomes 4, 1, 0, 1, and 4. Now x squared plus 2 is basically just adding 2 to x squared. So I'm just going to add 2. 4 plus 2 gives me 6. This gives me 3, 2, 3, and this gives me 6. Similarly, x squared minus 3, I'm subtracting 3 from x squared. So I subtract 3 from 4, I get 1. This gives me -2. This gives me -3, -2, and 1. Okay, so what do you guys notice about the table? All right, so let's take a look using our graphing software. So as you can see, I've entered our points, our table that we created. I entered that in here. Now let's look at what happens when I graph the points for x squared. Well, here are my points for x squared. All right, so I'm going to go ahead and get my function for x squared, and we see that obviously these points fall on the graph of y equals x squared. Now I'm going to click on the function x squared plus 2. What do we notice? Well, we notice that these points have now moved 2 units up, right? So for example, this point at 0 has now moved to 2. The point at 1 here has moved to 3. The point at 4 here has now moved to 6. Okay, so if I go ahead and click my function, what do I notice? I notice that the entire function, or the entire graph, has actually moved up by 2 spots, right? So the plus 2 actually takes the function fx and it moves it up by 2 units. Notice that it's only a vertical shift. It's not moved on either side, and neither has the shape or the size of the function changed. Okay, now let's go ahead and look at x squared minus 3. So this was your table for x squared minus 3. When I plot those points, what do you notice? I notice that the points have now moved down by 3 units, right? So obviously when I go ahead and graph x squared minus 3, I notice that the entire graph now has shifted down by 3 units, right? So the point 0 is now at the point -3. The point -1, 1 is now at the point -1, -2. So we notice that all the points have shifted down. Again, notice that the size or shape of the graph have not changed. What has changed is the orientation, and now that my graph is 3 units down. So then that begs the question, what happens if I add some number to x squared, right? So what if I had a graph, say x squared plus k, but I don't know what k is? Okay, so what would happen in that case? Okay, oh. So what would happen in this case? So here's my graph x squared plus k. Just notice that when k was 0, right now you see k is 0, and k is 0, it's exactly the function x squared. What happens when I make k positive, right? So making k positive, as I make k positive, you notice that this graph is actually moving upwards, right? So k is about 5, and you see the graph is moved up by 5 points, and as I keep increasing k, the graph just keeps moving up. Okay, again, the size and the shape of the graph is not changing. All that's happening is it's moving up. And if I come back to 0, well, the graph is back here. Well, then what happens when k is negative? So when k is negative, we notice that the graph actually ends up moving down. So here, when k was negative 3, we had seen previously that our points had moved 3 units down. And so as I make it more negative, it keeps moving down. And so we notice that k actually shifts the graph up or down. Okay, so then vertical shift. So suppose that k is 0. So let k greater than 0. Okay, then the graph of gx equals f of x plus k is the graph of fx shifted k units up, okay, and the graph of hx equals f of x minus k is the graph of fx shifted k units down.